Okay, so today we're doing our last section, day 1, section 5.6, and we are going to learn how to solve some exponential equations that don't have the same bases. So if you look at our first problem here, 2 to the x equals 5, notice 2 and 5 have nothing in common with each other. There's two ways that we're going to work this out. There is the law of logarithms and there is the change of base. They give you the same answer at the end, and on the WebAssign they ask you to give the approximate answer at the end. There's one way of typing it in, it's the change of base way. You can't type it in with the law of logs, but once you've got the approximate answer for this one, it's the same thing for this one. So we'll start off working it out with the law of logs, and then we'll do the change of base, and then we'll type it in and get the approximate answer. So to do the law of logarithms, what we do is we apply log to both sides, which some think about it as multiplying by log on both sides. So you put log on both sides of the equation. So we're going to put log 2 to the x equals log of 5, like this. Well, there's that rule that we learned a couple sections ago where that x would fall down to the front. So it would become x log 2 equals log 5, like this. Now log 2 and log 5 are just numbers. You could type those into the calculator because you have a log button on your calculator. But we're not going to type them in yet. Since this is x times log 2, all we have to do is divide by log 2 to the other side. So we would get x equals log 5 over log 2. Now that's the first answer. They say to give the exact answer, this is the exact answer for the first spot on your answers for the 4 answers that you have to give. Now for change of base, for these first problems, what you have to do is you have to take the original problem and you have to change it to its exponential situation, where we have to do that around the circle thing, and we have to go way back to section 1 where we did that, where we write log, and then the 2 goes in the bottom, the x goes on the other side, and the 5 goes in the middle. That right there is your exact answer for the change of base part of this problem. So you have 2 answers. For the law of logs, it's this. For the change of base, it's this. Now they ask on both of them for the approximate answer. For the approximate answer, we just have to be able to type this into the calculator. You can't type this one in. You have no button that says log base 2, but you do have a log button, one that just says regular log. You could type this one in. So you're going to actually type in log 5 divided by log 2 in your calculator, and you're going to get a decimal. The decimal that you should get would be 2.3219. Now I don't know on WebAssign what it says to round to, and they say on there what to round to, but this would be the approximate answer 4 decimal place wise, and it's going to go for both law of logs and of change of base, both answers. So let's do another one. Let's do one that has a fraction. Same situation. So I'm just going to get rid of this part and this part. I'm going to leave the law of logs written on there. And then I'm going to change up here the problem. So number 2, it's going to be with a fraction. Same situation. So we're going to have, in this case, 1/2 to the x equals 100. Exact same situation, don't be freaked out by the fraction. So for the law of logs, we're going to put log in front of this, and we're going to have log of 100 over here. On this guy, same thing, that x is going to fall down to the front. So we're going to have x and then log of 1/2. And then over here, we're going to have log of 100. This is just times. So all you have to do is divide by log of 1/2. So if I divide by log of 1/2, you have your exact answer. So your exact answer is x equals log of 100 divided by log of 1/2, and you have your first answer. Change of base, we change this to its exponential format. So the bottom thing goes into the base of the log, and it's okay that it's a fraction. So it's log base 1/2. The x goes on the other side, and then you've got the 100. And that's what it is. It's x equals log base 1/2 of 100, and that is your exact answer for that one. And then we have to plug it in to get the approximate. We can't plug this one in because we have no base 1/2, but we can plug this one in. So we're going to plug in log 100 divided by log 1/2, and for that one we should get, and it's negative, and it's okay. So I got negative 6.6439. So everything's good on that one too. Not that hard. Nothing too hard for this stuff. So one more of these, and then the very last problem that we're going to do today is super simple. So this one is the hardest one of these to do because there's an extra number involved. So we've got 2 to the 3 minus x power equals 5. So it's a lot like the very first problem, and we got this extra thing up there, this 3. We're going to start off the law of logs the same way. We're going to put log on both sides, so we're going to have log of 2 to the 3 minus x equals log of 5. And this 3 minus x is still going to fall down to the other side. So it's going to be 3 minus x times log of 2 equals log of 5. And I'm still going to divide by the log of 2 just like I did before. So I'm still going to divide this side by log of 2. I'm just going to be left with 3 minus x. So I'm going to have log of 5 divided by log of 2 over here. So I've got to get that x by itself. So I'm going to first move the 3 over. So I'm going to subtract 3. So it's going to go over there. So I'm going to have negative x equals log of 5 over log of 2 minus 3. So to get rid of that negative, wouldn't we divide by negative 1? So we're going to divide by negative 1, but we're going to divide by negative 1 on all of the pieces. So when I do that, I get x equals, when I divide by negative 1 here, the negative just goes in front of the log. So I get negative log 5 over log 2. And then we know negative 3 divided by negative 1 is just plus 3. So this is my exact answer. And we'll be able to type that in. That's not too hard to type in. Now for change of base, it's just like the way change of base worked on the other problems where I put all the different pieces based on the exponential format. So it would be log, the 2 goes into the little base, the 3 minus x goes on the other side, the 5 goes in the middle. Just like on this one, I've got to solve for x. So I'm going to subtract the 3 over. So I'm going to have log base 2 of 5, and then minus 3 equals negative x. That is not 5 minus 3. That 5 is its own little thing. You can't do 5 minus 3. And then I have to divide by negative 1, just like I did on the last problem. I'll divide everything by negative 1. So this would be negative log base 2 of 5, and then plus 3 equals x. So it's just like solving a regular equation. Once again, I still can't type that in because I don't have a little base 2, but I could type this one in. You could type in negative log 5 divided by log 2 and then plus 3. So if you type that in to get your approximate answer, you should get 0.6781. And it's the approximate answer for both of them, like I said before. Now I could actually squeeze number 4 over here. This is a different change of base formula. It's a change of base when you don't even have an x involved. It's called change of base. It's a very simple change of base, and it's a way that you could type in a equation kind of like these over here, but without having to do any kind of manipulation really whatsoever to your problem. So it's something when you're given like log base 6 of 18, and there's no x involved whatsoever. What you do, and like I said, it's very, very simple, is you take the log of the number in the big position, not the little base position, so log of 18, and you divide by log of what's in the little position, the base position, log of 6. And you just type that into your calculator, and you're going to get what the answer is, and that's it. So log of what's in the big position divided by log of what's in the little position, type it into your calculator, and you will have the answer. So it's just, in this case, 1.6131, and you will be done. That's it for today. So I will see you guys tomorrow for our very last video.